Hi everyone, my name is Tombal and I am a researcher at the CRIDS and at the Namur Digital Institute of the University of Namur. And today with my colleague Anthony Simonofski, we are going to present to you our discussion paper titled Artificial Intelligence and Big Data in Fraud Analytics, Identifying the Main Data Protection Challenges for Public Administrations, which is submission number 13.
So hi everyone, I'm Anthony Simonofski. I'm a colleague of Thomas. I'm working as a postdoctoral researcher at the Namur Digital Institute at the University of Namur, and also at the Faculty of Economics and Business at the TU Leuven. Both universities are in Belgium. Thomas and I, as you can see in the presentation slide, are working on the DG4FED project. This project is funded by BELSPO, the Belgian Science Policy Office, and it's a more global project in which this presentation inserts itself. The main research question the project intends to tackle is the following. How can big data be used in the Belgian Federal administration system to enable better public provision through new technologies such as AI and blockchain? In this project, we focus on three main areas. First, we want to research the impact of moral, legal, and organizational conditions on the needs of the public administrations, whether they are current or future. We also want to study the internal administrative decision-making processes and how they are affected by big data, AI, and blockchain. For that, we will investigate the role and independence of the executive decision makers. Finally, we will focus on the external transparency of the decision-making processes so that there is a true citizens' trust in technology and in the administrative system that is not only human-based, but also enhanced through the use of big data, AI, and blockchain. In this presentation, we'll focus on the impact of legal conditions on the administrative processes. For that, a little bit of background related to our research. The use of big data analytics to detect tax fraud or social security fraud has been examined in previous research, and it has been labeled as fraud analytics. It refers to a more global approach consisting of using analytics, a whole set of advanced analytics techniques, in fraud detection, investigation, confirmation, and ultimately prevention. It consists in three different stages. First, in the pre-processing stage, data is collected and cleansed for analysis from different sources. In the analytic stage, the different techniques are used to make sense of the data, either in a descriptive or in a prescriptive way. Finally, in the post-processing stage, the output of analytics is used by different stakeholders to support their work or their decisions. While fraud analytics can offer the promise of more efficiency in fighting fraud, public administrations also have to face additional constraints, such as the need to be trusted by the citizens, also to comply with certain legal requirements. Indeed, whether they use traditional or advanced analytic techniques, administrations consistently use more and more big data to deliver public services. In this regard, they often need to process sensitive data such as citizens' personal data.
And so while these legal requirements linked to the processing of personal data are well documented in the literature, as we outline in the discussion paper that you can find on the Zenodo platform, so we're not going to repeat all of this here, but without claiming to be exhaustive, we can underline here that several of these requirements, so for example, the fact that the data must be collected fairly and transparently, and that according to the purpose limitation principle, data needs to be collected for a specific purpose and can only be processed for that specific purpose. Linked to that is the fact that due to the data minimization principle, only the adequate, relevant, and necessary data for the fulfillment of these specific purposes needs to be processed. Furthermore, any fraud analytics process must rely on a lawful basis of processing, and in practice, it will often be a law, but this law needs to meet some specific requirements. Moreover, the GDPR also provides for several data subjects' rights. We're not going to list all of them here, but we're going to focus on two of them. The first one is the data subjects' rights to information. So the public administration need to take the appropriate measures to provide any information to the data subjects about the data analytics in a concise, transparent, intelligible, and easily accessible form using clear and plain language. The second right that is interesting is the data subject's right not to be subject to a decision based solely on automated processing. So there are exceptions to this right, of course, notably the fact of a fully automated processing authorized by law. But in such case, there will be safeguards that need to be implemented, such as the right to a human intervention. Anthony, if we can go to the next slide. And as said before, while these legal requirements are well documented, the concrete way in which they are integrated in the day-to-day practice of the public administration in their fraud analytics process remains to a certain extent unexplored. And moreover, to the best of our knowledge, no papers has identified the main challenges in practice that they faced in doing so. And so accordingly, our paper aims to address the following research question: what are the main data protection challenges in the fraud analytics processes?
And in order to answer these research questions, in order to shed light on the different challenges related to data protection, we examine two main case studies within the Belgian Federal administration: the detection of tax frauds by the Federal Public Service Finance, and the detection of social security infringements by the social security institutions. We opted for these two case studies rather than only one to improve the external validity of our research and to draw more general conclusions in this research. In total, 21 interviews were performed from August 2020 to December 2020 with stakeholders from a lot of different management levels, such as strategic, mid-level, or operational, and also from different backgrounds, either legal specialists, IT specialists, or management profiles. We can also say that we collected data about IT, managerial, legal, organizational practice, as we had to collect data in a broader scope for the project. But in this presentation and in the paper, we focus on the balance between the legal requirements and the implementations of these requirements in the fraud analytics process. Before going further in how the legal requirements were implemented, we first want to describe the two case studies we focus on and the fraud analytics process they use to detect fraud. First, the tax fraud case. As you can see in the figure on this slide, the tax fraud analytics process is divided in two main teams. First, there are the data miners who will detect potential case to be investigated among a large set of data. Then you have the e-auditors and the human controllers that will more investigate one specific case. We can say that the data miners have more an IT profile, whereas the e-auditors and human controllers more have a legal or tax investigation profiles. As you can see in the process, first, there is a step of data collection where the data miners will collect data from a lot of different sources, such as a tax fraud data warehouse, which is the main data source, but also from a complementary source, such as newspapers, commercial correspondence, accounting data, or any other relevant information. They will access this data while compiling a data access fiche to state their purpose of their request to access to this data. Then they will prepare the data, they will cleanse it, they will improve the data quality, and then they will apply data mining. They will detect some potential cases to be investigated based on some indicators or some fraud typologies. Then these potential cases are suggested to the e-auditors and human controllers that will investigate one potential case in depth in the human investigation case step. Then they can also use AI techniques such as text mining to make sense of a lot of documents, for instance, related to a specific case. Then they will iteratively work like that to investigate a specific case and sometimes give feedback to the data miners about the relevancy of the fraud case that was suggested. A different process is sometimes followed. Through input services, new cases are prepared through signals such as data leaks, complaints, newspaper articles that are upgraded as new cases after pre-investigation. Then this case will be suggested once again to the human controllers in the process I just described.
So for the social security infringement detection process, it's important to understand that a social security network has been created in 1990 in Belgium, in which all of the Belgian Federal public social security institutions, that I will later call SSIs, are structured around the Crossroad Bank for Social Security, so the CBSS. And so while these SSIs remain in control of their own sources of personal data, the CBSS acts as the central actor for the sharing between them, but does not itself store any data. It's rather a gatekeeper that is going to check that an SSI has the right to access data stored on or that belongs to another SSI. So regarding social security fraud, there's a difference between the types of techniques used to detect fraud committed by beneficiaries of social allocations on the one hand, and on the other hand, fraud committed by employers, health institutions, and independent workers, etc. So for the former, and this is the left part of the slide, the SSIs mainly rely on data matching techniques. So they do bilateral cross-checks between each other's database through the CBSS that are aimed at identifying incompatibilities in terms of allocations. And this is done either before or after the payment of the allocation. For the second type of fraud inspection, so the right side of the slide, the social security institutions, they mainly rely on data mining techniques through the use of the OASIS data warehouse, where larger quantities of pseudonymized data are compiled, and it's mostly on this one that we will focus for the rest of the presentation. And it's also worth mentioning, a last point, is that one of the SSIs is currently developing a new big data analytics platform to improve the data governance mechanism between the SSI. But so if we move to really the core of the presentation and the challenges that emerge, the first challenge that we have identified is the need to ensure the reactivity to fraud while respecting purpose limitation. So for tax fraud and for social security, we have two laws, and you will have the details in the paper. But there are two laws essentially that allow the tax administration or the various social security institution to do some data mining operations in a data warehouse. So there's one data warehouse for tax and one data warehouse for social security. And so it's nice to have these laws, but for some authors, the purposes of processing as they are defined in these laws is too broad. So to some extent, this is alleviated by the fact that for the tax fraud, the data miners will have to fill in, as Anthony said, a data access management fiche. And so in this DAM fiche, they are going to have to state the objectives and the purposes of the data mining and explain how this fits the organization's mission, etc. And similarly, for the social security case, prior to doing any concrete processing, they either need to do a data transfer protocol or they need an authorization from what is called an information security committee that is going to evaluate the purposes of processing. So there is some kind of refinement of what is proposed is suggested in the law, but of course this is not ideal, neither from a democratic perspective, because the concrete purposes of processing are not defined by Parliament, neither from a legal perspective, because the key elements of the personal data processing are not defined by the law, but in these secondary instruments. And moreover, while these mechanisms, they can be in conflict with the need for reactivity in fraud analytics, because indeed, in some cases, for example, customs tax fraud detection, administration, they need to react very quickly, and getting these authorizations, even if they're not perfect from a legal point of view, is still time consuming, and it can be challenging to precisely define the exact type of fraud that you want to investigate and to define in advance the exact purpose that you're pursuing. The second challenge is balancing data minimization with timely access to relevant data sources. So the same laws that I talked about before, they also provide for the types of data that can be used in the context of these data warehouses. But again, the same authors consider that, like for the purposes, the types of data that can be used are also defined too broadly. So once again, the fact that there is this data transfer protocol or the data access management fiche or the authorization request to the information security committee narrows down the type of data. And so in some way, it kind of matches the data minimization principle, so the idea that you have to specify which kind of data you have to use. And so this is a bit more pragmatic, because while we could imagine that the law defines the purpose is it's complicated for the law to define in advance all of the data that could be used. But nevertheless, this creates internal discussions about how much data they can use and how much data they can ask for in a timely manner. And the whole key is to be proportionate in this, but because even if they could have access to troves of data, they still need to find a balance with the citizens' data protection. A third challenge is to facilitate the access to information about fraud analytics for citizens. And in both case studies, citizens are generally informed about the existence of data, of these data warehouse and the data mining, but these laws do not provide sufficiently clear information, notably in terms of, as I said, the concrete purposes and the concrete data that are used. And while this is provided, again, in the data access management fiche, in the data transfer protocol, in the authorization of the information security committee, citizens do not have access, for example, to the DAM fiche, and the data transfer protocols and the information security committee authorization are kind of spread out a little bit across various websites of the administration, and it's difficult for citizens to access it, especially because the search tools are quite basic. So it's very hard for the citizens to have a good overview of everything that happens with their data.
A fourth challenge is related to the assurance that a truly critical human check is made of quasi-automated decisions. What it means is that for both case studies, we noted that even if the machine does not in itself decide that a person is a fraudster, the decision to identify a person and to tag them as suspicious could be qualified as a solely automated decision. Thus, question could be raised about whether the human intervention in this process remains sufficient, especially if the controllers do not question the fraud inspection suggestion they receive, as they rely on the machine to determine the cases to be investigated. If we look forward to the future, it's possible that in light of constant budget cuts, at least in Belgium, in the federal government, and the reduction of personnel, there is a risk that a few inspectors that are left will simply end up trusting the suggestion made by the machine without true critical thinking and true human checks. Such a scenario, we think, must be avoided to truly ensure a human check of suggested decision made by the machines. A fifth challenge relates to the balance between explainability and the need to ensure the confidentiality of the fraud analytics process. Indeed, for both cases, data scientists are able to more or less explain the reasoning behind the detection of the fraud, whether it is the indicators, the techniques that are applied, the typologies. However, it is complex to find a balance between being fully transparent to the citizens, to the people that are investigated about the data mining processes and the models that are used, and also the need not to disclose too much about the fraud analytics process, as indeed, as the public administration intend to detect fraud, we don't want the fraudsters to be able to adapt and to learn too much about the fraud analytics processes of the government. If they know too much, they can then learn to avoid being detected through these automated techniques. And it's a tight balance to find.
So very quickly, and as a final takeaway, as we're running out of time, we suggest some ways forward to address some of these challenges. So for example, we argue that in order to ensure the reactivity to frauds while respecting purpose limitation, the data processing authorization request, it could be slightly broader at first and then refined continuously throughout the process through this idea of iteration. And this could be done via a close collaboration between legal services and data miners. And another solution would be, for example, to anonymize or at least to pseudonymize, and to a larger extent, the data is pseudonymized right now, the data warehouse data in order, for example, to ensure privacy by design and privacy by default. Regarding the access to information, a solution that we suggest would be to centralize the publication of all these DAM fiche, data transfer protocols, authorization by the Information Security Committee in a single source, for example, the Data Protection Authority's website. And this would allow, for example, to have a centralized place of publication, and this could be combined with a performance searching tool that would allow to do searches based on the types of processing, the types of data, etc. And a good example of this is the City of Amsterdam's algorithm register website.
And the last lead for solution related to the balance between explainability and confidentiality, relating two different techniques. Explainable AI is a very buzzy term related to the use of advanced techniques that can be easily explained to the people of interest. However, their use in the fraud detection domain is currently under investigated. Another solution related to the balance between explainability and confidentiality relates to the use of heterogeneous techniques. We could, for instance, suggest that we would use a more advanced technique to investigate a specific case while using more simple, explainable techniques to detect cases to be investigated and thus be able to justify to a specific organization why they are being investigated.
So this was, in a nutshell, our presentation and our paper. We hope that this raises a lot of interest and maybe some questions, and we are really looking forward to discussion. Thank you very much.
Thank you very much.